what the horizontal asymptote is, it's an end behavior asymptote. And remember, anytime I say end behavior, these are the end arrows. Where do the arrows go at the end? As x goes to plus or minus infinity, as it gets very, very large, one direction or the other, the question is, y goes where? With polynomials, it's top, top, bottom, 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 top, top, bottom. With polynomials. With rational functions, it's going to be a little different. You're going to have multiple types of end behaviors. If I look at the graph of 1 over x, of course I know that x can't be 0, so x equals 0 is the VA, and I expect that to be the case, and that's what you see right here. So this graph is going to ride, in this case, because I'm looking at multiplicity odd, it's going to ride opposite directions. But that's not what this is about. What this is about is this guy right here. This is end behavior. The arrows. And this says what happens as x gets very, very large in a negative way. X is going to have to go to, in a sense, negative infinity. Let's not be cooperative. Do it down there. That means gets very, very large. So I'm going to essentially look at negative 1, negative 10, negative 100, negative 1,000, or 10,000. Looks like I've got negative 10,000 twice. Negative 100,000, negative 1,000,000, negative 10 million. Notice what happens. If I'm looking at 1 over x, negative 1, negative 0.01, this should be negative 0.1, negative 0.01, negative 0.0001, negative 0.00001. And notice every time I add a 0 to the x, I add a 0 in front of that 1, and it pushes it out. This is kind of what's the hand-waving part, and a little bit nebulous, and we are doing a little calculus here, is that as x gets larger in a negative way, y is getting smaller. And how small does it get? Well, it gets so small. If I were just to look at here, this is negative 10 million. Negative 10 million is negative point, and it's got 6 zeros and a 1. If I were to round this off to one place, it's 0. 2 places, 0. 3 places, 0. 4 places, 0. 5 places, 0. 6 places, 0. And essentially, and this is not a big number. 10 million is not a big number. We think it's big, but a billion is big. But that's really not really a big number. Trillion is big. You can be bigger than a trillion. That means I'm going to have a ton of zeros. So for all intents and purposes, as x gets very, very, very large, y is getting teenier and teenier and teenier, and it goes to 0. The same thing is happening on the other side. As x gets very, 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 very large, y is getting teenier, and so y is going to 0. So what do we say? we say as x is going to infinity, y is going to 0. As x goes to negative infinity, y is also going to 0. So if y goes to 0, then we say that y equals 0 is a horizontal asymptote. That says as I look at the graph, I put in my VA, which is x equals 0. I put in my HA, which is y equals 0, and it shapes the graph. Never crosses the VA. By the way, it can cross the HA. We won't, I'll do one example. In calculus, you can easily find it. Here, it's very difficult because we don't have the processes to do that. But it provides a wall, a floor, or a ceiling. So essentially what an HA is a floor for the graph or a ceiling for the graph. So if the graph is coming down, it's going to ride along the HA. If the graph is going up, the HA is going to be a stopper. And it's going to ride along the HA. Horizontal asymptote.